All right, let's just jump right in. If you're tuning into this explainer, you're probably ready to dust off those manual math skills and really get into the nuts and bolts of how numbers work. Look, today we're going to tackle subtraction, not just as that annoying chore you usually hand off to the calculator on your phone, but as this really fascinating multi-level progression. Think of it like a video game. Every stage builds on the last one, and by the end, you're going to have this deep, structural understanding of the whole system. So let's get started.
Here's our quick roadmap for leveling up today. First, visualizing on a number line. Second, setting up long subtraction. Third, mastering the art of borrowing. And finally, the boss level, subtracting negative numbers.
So, let's kick things off with level 1, visualizing on a number line.
You know what's really cool here is how we can completely reframe how we think about this. As kids, we're taught that subtraction is just taking things away, right? Like eating slices of pizza. But as math gets more complex, it is way more helpful to think of subtraction as actual physical movement. Specifically, it's movement to the left on a number line. You just drop a pin on your starting number, look at what you need to subtract, and literally jump that many spaces to the left.
Now see that in action. Say we need to solve 3 minus 8. A lot of people might freeze up because, well, 8 is bigger than 3. But we don't need to panic. We just follow our spatial movement rule. We start by dropping our dot right on the positive 3. Then, since we're subtracting 8, we just take exactly 8 jumps straight to the left. Count them out, we cross right over the 0, and boom, we land squarely on negative 5. It's really that simple.
And the beauty of this is that the spatial logic holds up perfectly even if we start in the negatives. Take negative 3 minus 8. Our starting point is already on the left side of 0 at negative 3, but the operation is still subtraction. So that core rule, exactly the same. We just move to the left. We take 8 jumps leftward from negative 3, going way deeper into negative territory, and we land right on negative 11. By just thinking of it as directional movement, we completely eliminate that common confusion around negative numbers.
All right, time for level 2, setting up long subtraction.
Now, to tackle the big numbers without reaching for a phone, we need some strict rules of engagement. First things first, alignment is everything. The larger number goes on top, and you have absolutely got to make sure your units, tens, and hundreds columns are perfectly stacked vertically. Second, you always subtract the bottom digit from the top one. And third, the golden rule here, if the top digit is smaller than the bottom one, you've got to borrow from the next column over.
Which brings us to our main challenge for this explainer, the boss battle. 8,345 minus 4,769. Now, just thinking about those numbers, you probably spot the issue right away. In almost every single column, the top digit is smaller than the bottom one. So, what exactly do we do when we just don't have enough value to subtract from?
Well, that brings us to level 3, the art of borrowing.
Let's break it down step by step. Step 1 is getting that alignment perfect. Picture 8,345 sitting exactly on top of 4,769. The ones are matched with the ones, tens with tens, hundreds with hundreds. This rigid structure, that's the scaffolding that keeps the whole math problem from collapsing. Okay, first hurdle. We look at the ones column on the far right. 5 minus 9. Well, 5 is definitely less than 9, so a direct subtraction is a no-go. We have to borrow. So we glance to the left to the tens column, where we have a 4. We borrow one 10 from that 4, which knocks the 4 down to a 3. We drag that borrowed 10 over to our ones column, add it to our 5, and suddenly we've got a 15. Now 15 minus 9, that gives us 6. First column cleared.
Moving left to the tens column, we hit another roadblock. Remember, our 4 was reduced to a 3. So now we're staring at 3 minus 6. Again, 3 is just too small. What do? We borrow from the neighbor on the left again, the hundreds column. We take 1 from that 3, turning it into a 2. We drop that borrowed value right onto our tens column, turning our little 3 into a 13. And 13 minus 6 is 7. Write it down and let's keep moving.
You probably know the drill by now. In the hundreds column, our top number is currently a 2, and we need to subtract 7. 2 is less than 7, so we look to the thousands column. We borrow from the 8, knocking it down to a 7. That borrowed value pumps our 2 up to a 12. 12 minus 7 is exactly 5. Boom, right down the 5.
Finally, we hit the thousands column on the far left. Our top number is a 7 and the bottom is a 4. And for the first time in this entire problem, the top number is actually bigger. 7 is greater than 4, so we can all breathe a huge sigh of relief. No more borrowing. We just subtract straight down. 7 minus 4 is 3.
And just like that, all 4 columns are done. Level cleared. To get our final result, we literally just read the digits across the bottom from left to right. 3, 5, 7, 6. Our final answer is 3,576. By methodically borrowing, moving right to left, we completely dismantled this massive problem, piece by piece.
All right, let's wrap this up with our final challenge, level 4, subtracting negative numbers.
Let me ask you something directly. What actually happens when you subtract a negative number? I mean, think about it. If normal subtraction means moving left on a number line, what in the world does it mean to take away a negative?
Here is where things get kind of mind-bending. It all comes down to the rule of reversal. Standard subtraction tells your brain, okay, go left. But a negative sign? That is essentially a command to do the exact opposite. So when you combine subtraction with a negative number, you're being told to completely reverse your leftward movement. And what's the absolute opposite of moving left? Moving right. Subtracting a negative is literally the exact same mathematical operation as adding a positive.
Let's put this into practice with one last example, 7 minus -3. Using that rule of reversal we just talked about, subtracting a -3 is identical to adding a +3. The equation just transforms into 7 plus 3. Visually, on our number line, you drop your pin on the 7, and instead of moving left for subtraction, that double negative forces you to jump 3 spaces to the right. 7, 8, 9, 10. The answer is 10.
So we've gone from basic number lines to juggling multi-digit borrowing, all the way to reversing directions with negative numbers. And here's the thought I really want to leave you with today. Math is not just a bunch of arbitrary, frustrating rules that you're forced to memorize. It is a highly logical, deeply connected system of spatial movement. And you just proved you can master it completely without relying on a screen. So the next time you face a complex problem, whether it's math or just life, ask yourself, are you just blindly following the rules you were handed, or do you actually understand the deeper logic moving the pieces? Thanks for hanging out with me for this explainer, and keep that curiosity sharp.